chapters in this HCIA-AI training session, and the first is the overview of AI. So in the first chapter, the key parts of this, the overview, sorry. The key parts of this chapter is, first we'll talk about the past of AI. That is, first we talk about very famous workshop, that is Dartmouth workshop, and that is the birth of this term artificial intelligence, and a lot of famous scientists and mathematicians gathered together to talk about, to discuss one topic, that is how to make machine simulate human intelligence, how to make machine as intelligent as human beings. So that is the first part of AI. And then, so the keyword is birth of AI. And then we talk about these three skills of AI. That is the connectionism, the actionism, the behaviorism, and also the symbolism. These three skills. So for symbolism, scientists think that our brain are made up by a lot of items, and these items or principles represent some specific meaning. And then there is connectionism. The scientists who follow this school believe that they're trying to figure out how we make sense of the world by explore the structure of our brain. Our brain are made up by a lot of neurons, so we use the equations to simulate the structure of the neurons. That is, connectionism are these very famous neural networks kind of algorithm that follow actionism. And then we talk about behaviorism, that is, we make sense of the world by interacting with the environment, and then we get some feedback, and we will adjust our strategy and adjust our understanding about the world, about the environment according to the feedback. So an example of behaviorism is reinforcement learning. So that is the part of AI, and these are the keywords. So then we talk about what is AI. So for this part, first we give the official definition of AI, a very long sentence. AI is a technology or methods to simulate human intelligence and expand human intelligence. And then we talk about hierarchy. That is a hierarchy of AI in industry from the lowest level, that is infrastructures, mainly included the hardwares, computing power, computing storage, and big data. And then the second level is algorithms, and especially machine learning and deep learning algorithms, which are the most commonly used algorithms today. And then some technology directions like computer vision, speech processing, natural language processing, and or decision-making system, and some subtopics, sub-technologies, that is image recognition, image segmentation, object detection, and speech recognition, and so on. That is the fourth level. And then we talk about the highest level. We can combine these subtopics together, and then we can solve industry problem, or we can have the whole industry solution. Like, for example, the autonomous cars and smart healthcare and smart finance. We all need techniques from computer vision, from speech processing, from natural language processing, from decision-making system. And the key parts, wait a second, I will switch to, so for what is AI, we give the definition of AI and also the hierarchy of AI in industries, and then we talk about the relationship of AI, artificial intelligence, machine learning, and deep learning. And here we need to remember this picture. This picture shows the relationship of AI, machine learning, and deep learning, and also for AI be implemented in industries, we need 4 elements, i.e. the 4 keywords to put AI in practice. That is, we need data. So we need data just like experiments to us human beings. We need to learn from data. We need to learn from our experiments. We need to induce some laws, some principles from our experiments, and then we can solve some similar problems. And then that is algorithm. Algorithm is some strategies or principles that how we learn from the data, how we extract some useful information from data. We need computing power, so just like we need food every day, and also we need scenarios. So these scenarios, just like the industry solutions, that is a 4 key element for AI. That is a 4 key elements of AI in industry. So that is the second part. So for second part, these are the keywords. And then we talk about the present of AI, how AI looks like today. So we just talk about some AI scenarios, like what we talk about smart healthcare and smart finance, fintech, and autonomous cars. So these are the AI scenarios. And then we talk about some applications in 3 different fields of AI in detail. That is computer vision and speech processing and natural language processing. And we have go over a lot of applications of computer vision, like facial recognition, iris recognition, and lip reading, and also some applications of speech signal processing and also natural language processing. So that is the keywords of the third part in the first chapter overview of AI. So then we talk about machine learning in not that details. We talk about the types of machine learning. We can divide machine learning into 4 types. The first is supervised learning and unsupervised learning, semi-supervised learning, and reinforcement learning. And we talk about the features of these 4 types of machine learning and give some examples of these machine learning types. And then we talk about learning that will be very, very commonly used and very, very popular and very, very useful, like transfer learning. So transfer learning means that we use a pre-trained model, and we can we use a pre-trained model, and we apply this pre-trained model to solve some similar task. So we just need to fine tune the parameters in the pre-trained model a little bit, so the model would work for the similar target task, like the speech classification for classified dog and cats model. And this is the original model, and this we can use this original model, the pre-trained model. The model works perfectly to recognize whether it's a dog or cat in your image, and we can use this kind of model to do some similar task, like a task to recognize whether it's a person or a bicycle in the image. So that is transfer learning. We use a pre-trained learning and just fine-tune the parameters a little bit so it can solve some similar task. And then we mentioned about that AI just still in the initial stage, is still weak AI. So that is the key point of the first chapter. That is 1, 2, 3, these 3 parts, and the left 4 parts are not the key point of our training session, and also not the key part of the certification exam. So then after the first chapter, we move to the Python chapter. We talk about Python programming. And so we go very fast. We go through very fast from the introduction to Python. So, and then directly to the data structures in Python. So there are some typical data structures in Python. Yesterday we talked about 1, 2, 3, that is list, tuples, and dictionaries. So here, let's have a review of these data structures. So here, for the Python chapter, the data structures, first we talk about, list. So list, to define a list, we would use a square bracket to define a list, just A equal to 1, 2, to define a list. That is a creation of the list, and we can modify a list once it be created. That is, we can change the values, elements in the list. So the list is changeable. So and a list is an ordered sequence, of arrays. So it's ordered sequence. So we can index the element. We can access the element from a list by index, and the index of a list is from left to right, is from the index from left to right, from 0 to n, 0, 1, 2, 3, 4, and from 0 to n. And the index of a list from right to left, that is the inverse index. So from right to left, from -1, -2, etc. So we can index a list. So that is the key point of list. So a list is changeable. So we can delete, we can insert, we can change the values of a list. So
sorry, Kelsey, I have one question.
Yes, please.
You said that the list is ordered. So what does this mean? That element will be in some sequence, some sort of sequence, or can be in any sequence, not in sequence?
Okay, I will explain. So what does it mean for list is ordered? That means they have specific order these elements in the list have specific order. This is the first one, and this is the second one, and we can have this. This is the third one, so they got specific index, like index 0, 1, 2. So that means the list is ordered, and then we will mention that dictionary is unordered. Dictionary don't have, it's not an ordered sequence. So that means we cannot index.
So, sorry.
Yes, please.
In list, element cannot be random. It should be in order like A, B, C. Cannot
Random.
be randomly B, A, D, A, like that.
So for example, this is a list 1, 2, 3. So if we change the order of these elements like this, 3 to 2, 1, 3, it's these two are different, right? Because it's ordered. But if it is unordered, like here, if we define state 1, 2, 3. So a set is not an order sequence. So this set 3, 2, 1, they are the same. So that is the meaning of unordered and ordered sequence. So, and okay, one thing need to be mentioned is that. Okay. So we will. I mean, one thing need to be mentioned is that if we index, if we access, if we want to pick up elements from the list, and here is a rule that, for example, if we pick up, get elements from list A, like this A, and if we want to get out of the first two elements, that is, we want to pick up 1 and 2 out of this list, we need to code like this. So from 0 is the first element, and 1 is the second element. We should write like this.
If I can say something about this ordered thing, basically a list is ordered, but it doesn't mean that the elements inside the list has to be in sequence. What it means is that there is always specific index for accessing the elements of a list. For example, in this list we had 1, 2, 3. So 1 would always be on index 0, 2 would always be on index 1, and so on. But for in case of dictionary, this is not the case. There is no predefined index from which you can access the elements. This is what ordered means.
Yeah, thank you.
Thank you.
So to pick up the elements from a list, so like if we want to get the first two elements from list A, we need to use expressions like this from 0 to 2. So that is the left is closed and the right side is open. So that is, we will pick up the first element, but not the element, the index 2, the third element. So that will be the output. And then the second data structure we talk about are tuples. So to define tuples, we will use expressions like these, like A equal to the parentheses followed by 1 and a comma, 1 and a comma. If we don't add the comma, I will use code to share. Wait a second. So to define a tuple. Oh my God. We need expressions like this. Now A is a tuple. We can check the type of A. So for the program, for the computer to identify whether A is a tuple or not is by the parentheses and also comma. So if we define A like this, and we check the type of A1. We check the type of A1, it will be a int. So the program will think that A is an int. So we need comma to identify, comma and the parentheses to identify, to tell the program that A is a tuple, not an int. So, and another key feature of tuple is it's unchangeable.
Eunice, can you is it on
yes,
my glass?
please. Yeah. Yes, please. Any question? Okay. If there's no question, I will continue. Are you recording? Yeah. So the tuples, first, how to create a tuple, and another key feature that is we cannot change the element. We cannot change the element in a tuple.
जहाँ पे हमें अगर लेकिन वो प्रोसीजरल जो डेविएशंस हैं वो उस टाइम तक हम नहीं कर सकते हैं उसको मेरी क्लैरिटी उस टाइम तक नहीं हो सकती जब तक मुझे पता ना हो कि हम एग्री किन प्रोसीजर्स पे कर रहे हैं सर इसीलिए मैं आपसे ये कह रहा हूं कि ये मेथोडोलॉजी
Please, if you don't if not any question,
Somebody is calling someone else. Mute them.
please, if you don't have any question, please mute yourself, because otherwise we will hear a lot of noise. Thank you so much. Thank you. So, for example, here we define a tuple that is A1. So for this tuple, we cannot change the value of the elements in this tuple that A1. If one change the first element, that is A1, 0. If one change this 1, the value of this 1 to maybe 10, we will have a view of the type arrow because a tuple is unchangeable. But here, if we define a tuple A2, so it's a tuple A2, and in a tuple, the data type of the element can be different. So the first element can be a list or can be a string, can be int, can be float. And so the first element we define a list in this tuple, and the second element is a number as a int, and the third element in this tuple we define a string like this. We can use single quote, double quote, or triple quote. Here, that is Python, and we can check. Okay, this is a tuple we defined. It contains list, int, and string, and the string. So now the tuple is unchangeable. We cannot change the value of these elements, but here is a list, but we can change the value in the list. So that means we can change this element in the list, we can change this 1 to 10. So we access this element. So this list is the first element. So value is 0. And this 1 is the first element of the list, that is 0. So we can change it to 10. So there's no error, and we can check A2 automatically. So for GPU notebook, we don't need to use print. If one want to print anything at the last command, at the last line of a cell, we don't need print. So here we can check A2. So we successfully change 1 to 10. So that is the key features of tuples, and also the index is the same left to right from 0, and the inverse index is from -1, -2. And that is list. I will highlight tuples, and then we talk about dictionary. So to create a dictionary, we will use expression. We will use curly braces to create a dictionary, and in between, within these curly braces, there will be a lot of key value pairs like key 1 and value 1. So, and we will use command to separate different key value pairs, and we will use colon to collect the key and the corresponding value. So here is key 2, value 2. So we go down. So here to define a dictionary, and for a dictionary is not an order sequence. It's not an order sequence, so we cannot index. So we cannot index use expressions like this to pick up key value pairs from a dictionary. We will see key error. So a dictionary is not an ordered sequence. And we use key value pairs. So in a dictionary, every key, the value of every key should be unique, but the values could be the same. So to pick up the keys values and the key value pairs from a dictionary, can use expressions like these: the dictionary keys, the dictionary values, a dictionary methods, and it will return keys values or key value pairs from a dictionary. So that is how to define a dictionary and how to pick up the key value pairs from the dictionary. So that is what we talked about yesterday. And so now we will continue to talk about some more Python programming basics. So maybe before that, there's something I need to mention. The first one is the WeChat group, because of the security verification, you cannot join the WeChat group. But it's okay. If you have any problem, you can contact me by emails. So again, I will show you guys, here, this is my email. If you have any question, please contact me. And another thing, a lot of you guys send emails, ask for the training materials and the recordings. I've read, because of the information security problem. So information security reason, I don't have any permission to send you guys the training materials or recordings directly. So I've sent it to to your local manager, to Fatima and Bila, and they will share these training materials and the recordings and also Jupyter files with you guys. So two things. First is the WeChat group. If you cannot join the WeChat group, is okay, no problem. If you can send me email, we can contact by emails. And another thing is that about the training materials and the recordings and Jupyter files, I've already sent it to your local manager, and they will share these training materials and Jupyter files with you guys. So we will go back to our lecture. So first, dictionary. So no, not dictionary. So next, we're gonna talk about another data structure in Python. That is, sorry, where are you? That is set. So set also as an unordered sequence in Python. So to define a state, we need to use, for example, curly braces to define a state, like 1, 2, 3, 4, 5, and this is a state. And the key feature of a state is that every element in a state should be unique. The value would not be repeated. So, however, I defined a state like 1, 2, 3, 4, 5, 2, 3. There is 2, 2, and 2, 3. But if I print the state C, so it only contains 1, 2, and 1, 3. So the values in the state, the values of elements in a state should be unique. That means we can use state to delete some repeated elements. For example, here, if I define a list, here is my list. That is 1, 2, 3, and 2, 3, 5, and 43. So there are repeated 2 and 3. So if we want to delete the repeated value in this list A, so we can change A into set. So we can change A into set, use expressions like this, and we can convert back to list. So change A, convert A to set, and then convert back to the list. So we can print after this expression, A becomes like this. Every element is unique. There's no repeated values in B. So that is the first advantage of sets. Then that is the usage of the data structure set. And another advantage of set is if we define a set, we can use it. We can do interaction. We can compute the union between two sets, or we can do difference between two sets like this. Here we define a set C that is 1, 2, 3, 4, 5, 6, and here is another set here that is B. So we can compute the interaction of these two states. So we can use expressions like this to compute the interaction, or we can use C dot interaction state B to compute the interaction between C and B. And also an example to compute the union between two states. So we can use expressions like this to compute union between two states, or we can use C dot union state B. So the output is the union of two states. So that is the fourth. That is the fourth data structure in Python. We call it state, and to define a state, also we use curly braces, but in these curly braces, there is no key value pairs, just elements in these curly braces, like 1, 2, 3, and every element should be unique in a state. Should be unique in a state. So that is the key feature of the state, and we can compute the interaction or union if we use state. So that is the data structure of Python, and then we will continue to talk about very important part, and every programming language will talk about the conditional statement and the looping statement. So in this conditional statement and the looping statement, the first we will talk about is if statement. So we will talk about if statement, for statement, and while statement. So to control the execution. So here is a grammar to define a if statement. So we need keyword. So here, if is the word in green, so this is a keyword. So this is a keyword, and then if the keyword space followed by the condition, followed by the condition, that is, we will judge if we meet the requirement or not. So, and colon, and then the next is indentation followed by the statement. That means if score is, if we input a score, if the score is in between 100 and 19, so we will do the statement. We will do the statement print excellent. If not, we will try to do that is else means else if means if the score is in between 90 to 80, and it will execute this statement. If not, that is another else if, also a keyword, and followed by the condition if the score meets the condition, that is the score in between 0 to 80. 0 to 80, we will print million. And otherwise, that is else, also a keyword followed by colon, and then we will use a indentation type. We will use an indentation that is type then to execute the statement print back. So we will try to, here we use a built-in function here. This built-in function is input, that is ask users to input something. So here, input, please enter your score. So here, maybe my score is 85, and please Oh, wait a second. I will press enter. I should press enter. If I enter 85, that is input. So the score will be 85. And now this score 85 is a string. We need to convert the string into float. So here we use another built-in function in Python, that is float, to convert the string into the float. So here the score should be a float 85, and then we will do this first condition. If the score meets the first condition, so the score is 85. It's not in between 100 and 19, so it will jump to the second condition, that is if it's in between 90 to 80, so it's in between, it meets the requirement, so it will execute this statement, that is print good. So that is if statement. So the second one is for statement. So here is the grammar to define a for statement. Oh my gosh. Okay, I'm restarting the kernel. So here is the grammar to define a for statement, and for for statement, it can, hey, here. So for the for statement, it can traverse any items. It can traverse a sequence like list, like dictionary or string. So this is the grammar for for looping for statement. So also keyword for, this is a keyword in green, and we will traverse this we will traverse the range. So range 0 to 10 means, for example, range 0 to 10, and the output will be 0, 1, 2, 3, 4, 5, 6, 2, 9. So I would be 0 for the first time and do the follow statement. That is do the follow statement. That is first time I equal to 0 and print I equal to 1, print I equal to 2, print I. So that is the grammar for followed by I or other, N or M, and in. Where is I? So I will be in range 0 to 10. That is, I will be traverse 0 to 10. And here is the output from 0 to 9. So the left side is closed and the right side is open. And here is another example. We can traverse a dictionary like this. Here, A is a dictionary. We can traverse A, from the first element to the third element. That is 0, 1, 2. So here is the output. So that is the basic grammar of for. It can traverse any item of a sequence. So for while looping, here is the basic grammar of while looping. If we know when to stop, if we know the stop condition, so we can use the while loop. For example, here I equals to 90, and I will know if I is smaller than 100, and it will meet the requirement and it will execute the loop body. It will execute the loop body. So if here I is smaller than 100, and here I will execute the loop body I equals I plus 1, and then I will print I. And the basic grammar is we will also use while the keyword and space followed by the condition and then colon and in the loop body slash with indentation. So the indentation means the loop body. So with indentation, the type, and it will execute the loop body and we can run this cell. So the output will be like this. So for print this building function, for example, here we use print I and there will be this output value will be in different lines. But if we use and, so it will be in the same line and ended by a space. So we will separate this output. And here is a nested loop. So for nested loops, that means Python allows one loop be nested by another loop. For example, in the while loop, the loop body, we can use another conditional statement or loop conditional statement or loop statement. So for example, in this while body, loop body, we use if and another if for I is smaller than 9 and I equals to I plus 1, and we will judge if I is equal to 3 or not. If I is not equal to 3, it will jump to the next condition, that is this loop, if I equal to 5. If I is not equal to 5, so it will not execute print 5, and then I equals to I plus 1 here is the result. So that is the conditional and looping statement. We talk about just the basic grammar of for, while, and if this statement, and we can use listed loop. So one loop can be nested by another loop. So then we will move to functions, how to define a function. So also the basic grammar to define a function, we will use expression like this. Also the keywords like def for define, and followed by space, and then the name of your function. And then followed by parentheses. So in between the parentheses, we can enter the arguments or the independent variable into these parentheses. And here we use colon, and in this function body, we use indentation to identify that it is the function body of this function. And here is the function body, it's a if else statement. So that is the absolute value of x. If x is greater or equal to 0, it will return x. Otherwise, it will return minus x. So for example, how to call a function. So we will use the name of a function, that is my ABS, the name of a function, followed by the parentheses and the arguments you put in. So here x equal to -2, and we can call the function we've defined just now. So that is 2. So if if you want to define the function and there's nothing in your function body, and we can use another keyword that is pass. So there will be no arrow, otherwise there will be arrow. So for Python, there are a lot of built-in functions. For example, we use a lot of built-in functions, like print is a built-in function. Here, print is a built-in function. And int, float, string, these functions are all built-in functions. That is the common used built-in functions in Python. So here is how to define a function, and maybe we will have 10 minutes rest break, and then we will continue to talk about the keyword arguments for a function. Here I screenshot the grammar to define a function. We need keyword def, and we need the name of this function and the argument put in the parentheses and followed by colon, and in between we use indentation to identify then this is the function body of this function. So here is a function body, it's a for loop, and then you can decide whether your function have a return variable or not. If there is return variable, we can use return another keyword and space followed by the variable you want to return. So here is the grammar to define your own function, and then we will talk about the very important part to define a function, that is the keyword arguments. So to define a function, we need to identify the parameter of your function. So for example, here we define a function, the name is person. So for the person function, if we want to call this person function, the parameter we need to assign as the name, age, and followed by these two, that is periodic arguments. That means this name and age is a keyword, argument, and these two arguments are the arguments when we don't know the numbers of arguments we want to input to the function. That means sometimes we are clear about when we define a function, sometimes we are clear about how many arguments we would assign in the function, but sometimes we may have no idea about how many arguments we would assign when we call the function. So we will use the periodic arguments. So a periodic argument is used to solve the problem that the number of the input parameters is uncertain. So to define the periodic arguments, we can use expressions like this. We can use also the single star, or we can use double star. These two are both the periodic arguments. So if we use single star, that means the parameter, the arguments we input will be converted to tuples. And if we use double star, that means the arguments we input into the function will be converted into a dictionary. So here we will have some example. For example, we want to collect the information of persons, and we want to collect a lot of samples to build a machine learning model and to predict their scenery, or to predict their not salary but other things. So here we collect the information of a person. So first, the basic information of a person, you need the name of the person. Oh, so then notice, please change your name to name plus university. So name plus university. So that we will identify who are you. Otherwise, we got no chance to know who are you, and name plus university. So we will go back to the keyword arguments. So define a person name by age, and followed by 2 Baryonic arguments, the single star and double star. When we don't know the number of input arguments, so first we need to collect the name. We need to collect the name of this person, and also we need to collect the age of a person. So we just got one name and one age. So these are all one name and one age. And maybe we got a table, and in this table, the second column is maybe the feature. You can write down your features. So the feature can be a lot of features, hobbies. So the third column is you can write down your hobbies. So to collect the information about one person's hobby. So we have no idea how many hobbies you have. So we will use the Baryonic argument, and here we use single star. We use this single star. So we will convert your hobbies into tuples, and another maybe some other private information. I have no idea what kind of private information you want to give it to me. So I will use another column. You can write other private information, so I can collect this person's information. So here we will use we will use a double star. So for double star, we need to convert the Baryonic argument into dictionary. So we need key and values. So here is a function we defined, and we can print. We can print the name, the age, and the hobbies and the other informations. For example, okay, here is the function we defined, and we can call this function. So we can call the function. If we call function like this, person Michael, and there will be a type arrow, because the name and age are keyword arguments, and we have to input these 2 parameters. We have to input both name and age, otherwise there will be type error. So for example, if we successfully access the age of Michael, maybe 25, so there will be no error. See, so these Baryonic arguments are optional, but these 2 name and age, these keyword arguments are a must. So here is the grammar to call the function. So if sometimes some people don't want to tell you their age, so and don't want to tell you their age, but also like this, Michael don't want to tell me his age, but I don't want to see arrow. If you don't want to see arrow, you can use this. So this is the argument with default value. So here the default age is 25. If anyone don't want to tell you her or she's age, so their age will be 25. So we can run. Also, we should run the cell, redefine the person function, and run it again. So here, although Michael doesn't tell me his age, but I got a default value. His default value is 25. And then here we collect the information of another person, and his name is Bob, and his age is 35. And now he gave me some more information, more private information. For example, his hobby is music. Like, so I got the information about Bob's hobby, and he put some other private information. For example, where did he live? Where does he live? For example, if he lives in Beijing. So, for example, you need to tell me what kind of private information you fill in. So here, the private information, the keyword of this private information is city. So that is key. And the value, which city? Sorry, what happened? Wait a second. So which city? So that is Beijing. So that is a key value pair. So this is a 2-star double star periodic arguments, and it will be converted to dictionary. So we can call this function and have a look. Here we collect and Bob's personal information. That is, his name is Bob, and age is 35, and he got a hobby. He write down one hobby, that is music. So here the input argument will be converted. With the input argument, the data will be converted into tuples like this, the parentheses, and other information here, so will be converted into dictionaries like this, city and Beijing. And another example, that is the same. So here, another person and his name is Adam, and age is 45, and the hobby is maybe painting movies, and here's a list. I got no idea what does this list mean, but he feel this black, and we can run this cell. So name is Adam and age is 45, and they got he got hobbies like movies and paintings, and here's another hobby. I have no idea what does this list mean, but it's a hobby because this list is not a key value pair. It's not a key value pair. There's only values, not keys. So, but the gender and the job is a key value pair. So it identifies the key and also the corresponding value. So these will be put into a dictionary. So other information, gender is name and job is an engineer. So that is the example of the keyword argument. We got keyword argument, and we got argument with default values and also periodic arguments when is used to solve the problem when we have no idea about the number of input parameters. We can use periodic arguments with, if the single star periodic argument, it will convert the data into tuples. If it's double star periodic argument, it will convert data into a dictionary. So these just some other examples. We define a function. We define a function that it has a lot of parameters. It has a lot of parameters A, B, C, and also periodic arguments with single star and also double star. So C got default values. So if we didn't input the value of C, so the default value of C is 0, and A and B are a must. So we have to input the value of A and B. Otherwise, we will encounter the type error. So that is how to define a function and the keyword argument in Python. So I didn't talk, we didn't discuss these grammars in very detail because some of you already have a very solid experience in Python, but some of you are new in programming. So we need to take care of everyone, and so we choose the in-between, not talk. We choose the in-between, not talk about these grammars in very detail, but goes through also one by one. And then the next part we're going to discuss is the object-oriented programming. So the object-oriented programming actually is the class, how to define a class, and the class variables and the data members, and also how to inherit the class, the parent class, and the child class. So here, that is how to define and use a class. So in a class, that means a group of something, a group of items that have something in common. So here we define a class. So this class, this group of items, this group of things are animals. So animals have a lot of things in common. For example, we define this class. So the grammar to define the class is, for example, like this here, class, the name of this class, and followed by the keyword class space. The name of this class is animals, and the parentheses and colon, and then we will go into the body of this class. First, we got define init. That is a property. That is a property of the things of the items belongs to the class animals. So every animal got a name. They got a name. The dog, the cat, they all have a name, specific name, and every animal got a age. How old is it? Is he or she? And also, animal can breathe. Animal can breathe. So these are things in common. They can breathe. This is the first method. We define a function. So here we define a function, breathe, and followed by the self. Followed by the self, and then we can print. This is the function body. This is a function body of the brace. And for animals, they have some other features in common. That is, animals can move. So we can define other methods, other functions. That is this move function. So animals can eat. Animals can eat. So in this class animal, we define two methods and two properties, name and age. The methods, the functions are breathe, move, and eat. And how to how to call a class, how to create a class instance. We will use like this. First, the name of this class is animals, and we need to input the property that is a name, and the age that is a name, the name and the age. We need to input the property of this class. So for example, here, the name of this animal maybe is Katie, and her age is 5. So here is an instance we've created, and we can check the name of this instance, that is example.name, and we can check the age of the instance, and we can call the method in the instance like this. The name is oh, sorry, we need print. So here the name of this example is Katie, and the age is 5, and we can call this method breathe. That is, it will print breathing. So Katie is still alive, it will breathing. And here in this method, it can call the property. It can call the property of the animal. That is, it calls the name of this animal. So that is the grammar to create a class. We got the keyword class and the space followed by the name of this class, and the parentheses followed by colon, and then indentations, that is the body of this class. And here is a special method, that is the init method. It allows an instance to have some attributes or properties in common, to have the attributes of class templates from the beginning. So every animal got a name, got an age. So that is a grammar to create a class. So next we're going to talk about is inheritance, the class inheritance. That means here we create a class. The class is animals. So animal has a lot of things in common, but we can also divide animals into different branches. Like we can, the dogs belong to animals, and the mammals belong to animals, and cats belong to animals, and dogs and the cats have something in common. So they are all have something in common as animals, but they are also different. They also got different features. So the animal can be the parent class, and we can define other class. So this class can be the child class of these animals. So these child class have all the features of the parent class animal, and we can also create some new features of this new child class. For example, if the child class want to inherit the features of the parent class, we need to use expressions like this class and space followed by the name of the new child class, that is mammals. So mammals belong to animals. It have some common feature of animals. And so in the in the parentheses, we will identify the name of its parent class. So the name of mammals parent class is animals. So here are animals. And so for animals, they have their own feature, that is maybe breastfeeding. They can feed the young generation. So here we create a child class named as animal, and we can create the instance of the class animal. That is the name of this animal. Also, we need to input the attributes of these mammals. So the name of these mammals is Ruby, and the age equal to 4. So we can check the age of the cat, the instance cat, and we can check the instance. Own feature that is breast seat, and we can check another method. For example, we print the cat's age that is 4, and we call the breast feet example method, and the output will be a print feeding young generation, and we can use cat move. We can call the method move. That is the method belongs to all animals. It can move, so it will print moving. So we can also let the mammals become a parent class and create its own child class, like these cats. Cats is a child class of mammals, and here cats got their own attributes or properties. That is spots. How many spots of this cat? So we can use init mass. We can use an init method to define the cat's own attributes or properties. And also, cats got some other features that mammals don't have. Like cats can catch mouse. Yes, please.
Will you please explain the word keyword that is self? I'm not sure what self is doing here, and also the use of init function. Are they keywords?
You mean the init function?
Yeah.
So init function, this method is a special method. So it will allow instance, for example, the instance Katie, to have some attributes of a class template from the beginning. So that means, so here the init method, for the init method, we define a lot of attributes or properties of this class. So all the instance that belongs to this class would have the attribute like name, age, and spot.
Exactly. So, use of this self keyword. I'm not sure how to use self in
self here means the name of the instance, but now when we create a class, we have no idea about the name of the instance. It represents the name of this instance. For example, here self.name, if we create an instance, that's the name of this instance is Katie. So here self becomes to Katie.name. So here self just, it's not a keyword. I'm not sure if you notice, you can change self into any other word.
All right.
Yeah.
Excuse me, ma'am.
Yes, please.
Ma'am, why do we have to use object-oriented programming for applying artificial intelligence?
do you have to use object pro? Of course, no. But usually we will create a class, so your program, your code will be more convenient, more clean, and so we define something, a class, and they got some method in common, and then another. So next time we can call it directly, and so it's not a must, but we suggest you use this object-oriented programming sort. It's not a must. So here, this self actually represent the name of the instance, but when we create a class, we have at the beginning, we have no idea about the name of this instance, so we use self to represent. So the initial method, so is a special method. It's a special method that to define some attributes or properties in common for this class. And you can also delete this initial method. So if you delete this initial method, so there is no common attributes for this class. So if we delete this method, we will not see any. There will be no error. But usually we will use this init function. So it's not a must for deep learning or machine learning to use the object-oriented programming sort, but we suggest we better use it, but it's not a must. And so we will continue to talk about the class inheritance. So here, cat is a child class of the parent class mammals. So here is a grammar to inherit the mammals attributes and also methods. So, and it can define some own attributes or properties of cats. It got spot. There how many spots for this cat, how many spots does this cat have? So it got some special method, special technique, that special method, special function that is cat can catch mouse. So we define a function that has catch mouse. So next time we can call the function. Like here, we create an instance that is Katie, and Katie belongs to cat class, and the name of this Katie of this instance is Katie, and the age is 10. How many spots it got? That is 10. So we also can give these attributes a default value. So that is the spot equal to 20 if we don't input the value of the spot when we create an instance. So here is an instance Katie, and Katie is a instance of cats, and so it also Katie is also an animal, and so animal is the class, is a parent class of mammal, and the mammal is a parent class of Katie. So Katie can breathe, and Katie can catch mouse, and that is the class inheritance. So
Kelsey, I want to add something regarding object-oriented.
Yes, please.
For example, if we have data and we have some features like feature A, feature B, C. since every object of a specific class have variation in their features. So I think using this object-oriented programming, we can access the particular feature of a particular instance or example. So
Okay.
am I right?
Yes, yes, okay. Thank you so much.
In this case, it provides us the flexibility to access any object and its characteristics or properties or features.
Okay. Yes, yes. Thank you. If we use object-oriented programming,
Yeah.
sort our codes will be in a very beautiful structure. So if we don't use this object-oriented programming sort, so it will be easily become a very messy. The code will be.
Since ultimately we have to classify object into different classes. So
yes.
Using this, it will be helpful for us.
Yes, yes.
For distinguish different objects.
Yes.
Okay.
Oh, thank you so much. Thank you.
Okay.
So here is the class inheritance, and then we will talk about the class attributes. It can be private attributes, or it can be public attributes or public variables. For example, if we define the public variable, it will be defined like this. This is a public variable. So if we want to define a private variable or private attribute, so in the front of the name, we will use two underlines. We will use two underlines to identify as a private variable, or it's a private. It's a private attribute. So we can only use these private variable attributes within this class. So that is the object-oriented programming sort. And then the next section, okay, we will go back to the slides. The next section, we talk about the conditional looping statement and the functions and object-oriented programming. And next 1, 2, 3, next 3 section is not that important. It's very important, but if we go through one by one, for those who are very familiar with Python, may think it's very boring. But for those who are new in programming, it's impossible to remember these grammars. So we will go through very quickly. So when we program, if we need this some specific methods or functions to process the date, the time, and we can Google it and how to do it, blah blah blah, and you will find a lot of pages and a lot of websites to tell you the correct answer. And also for regular expression, and the regular expression is a very useful module in Python. So it can match some specific, strings. It can match some specific strings from documents, or from a document, a sentence, or paragraph. And the last section is the file manipulation. That is, we can open a file, we can create a new file, and we can write some content into the file, and we can save the file. Any question? Okay, that is the last 3 sections, so we will go through very quickly. For these 3 sections, we just need to remember why is the function of the regular expression, where we can use regular expression. So next time when we want to use regular expression, next time when we solve some problem, when we want to solve some problem, we want to create some project, here maybe we will know here we need to use regular expression to process these files, these sentence, these paragraphs. So we know we would use regular expression, so we can Google it because there is a lot of methods and a lot of attributes. It's impossible to remember all of these. So we just need to know what does the regular expression for, and we don't need to be very clearly about the syntax of these regular expressions as a beginner. So we will go back to the Jupyter notebook files. So the first section is about date and time. So in Python, there is a package or there's a module, we call it time. So this time module is used to process time. So we can import this module. Here we import time, import this module, and we can use time.local time. So to access the time now. So that is a time now, 2020, and May 12th, the hours and minutes, seconds. So we can change the format of this time. We can change the format of this time like this. There's a lot of functions and methods. We don't need to remember this. And we can also get the local time, And usually when we create a model, when we train a model, we want to know maybe, especially for machine learning or deep learning models, we want to know how many time it spends to train the whole model. So we can use this time module, use time.time to record what time is it, that is a start time, and then we can get the end time, that is time.time, that is time.time, and here maybe some other functions, that is the start time, that is the end time. So the end time minus the start time, and we can calculate the time that it is spent to execute these functions, these training process in between the end time and the start time. So that is just an example how to use time, this module. And we can get the local time. Also, we can get the calendar of the month, the calendar of these special months. And here is a building module in Python, or we call it calendar, and we can import calendar. And here, calendar months, we can call this method, this function, and input the year and the specific month, and it will output the calendar of the specific month is January. And there's a lot of other useful functions, and we can get the calendar of the whole year of the whole year, also called the calendar module, that is PR core. So that is date and time. There is a module in Python, so we call it time. We can import time to get to the local time and to count the time. So the next section is about regular expression. So regular expression is a very useful expression. We can find some specific, we can find some specific strings, specific set of strings from the articles and from the paragraphs. There are some useful methods. There is some useful methods like operations like this. So also we don't need to install this regular expression module. It's a built-in module for Python. So we need to just import here, import RE. So RE means the regular expression model, import RE, and in RE there are a lot of different method functions that is useful. So here, the first, we just want to give you some example. For example, the re.match. So we will match the txt. That is a sentence. Here is a sentence. So this sentence is AI, welcome to Huawei HCIA-AI online training course. So happy to meet you here. Hope you are enjoying AI. So that is a sentence, and we can use the regular expression to match some specific strings. For example, we want to use AI, this string, to match the txt. So it will match from the start. So it will match from the start. So if the first two character of this sentence is not AI, upper, not lower character, so it will return none. So the match failed. So we can also use another method. So search, that is RE search, also use this pattern, this AI, this string to search. So here it will not search match from the start. It will search till it found AI. So it found AI. So AI, this pattern is at here, this location from 22 to 27. So when it found the first pattern, the first AI, it will stop. But here we got another AI. So we can use find all and also input the pattern we want to search from. We want to search and also the sentence. And it will output, there is two AIs, it will output the pattern matched. So that is the example. We use regular expression to match some specific patterns from a string. So there's another functions like here. Also, we take this sentence as an example. This RA sub means we can delete some certain pattern and replace it. For example, here we want to delete AI. So here is a pattern we want to delete RA sub. Here is a pattern we want to delete, and the 9 is the pattern we want to use 9 to replace AI in this sentence. So you can run it. So all AI are replaced by 9. So that is RE sub. So here's just another example. The phone, and we can use RA sub to delete all the decimal numbers, and represent these decimal numbers by D. So that is an example of RA regular expression. And so if you want to find any other commonly used operations in regular expression, when we process some articles, some TXT files, CSV files, and you can go to the homepage of Python and you can find text about the regular expression operation there, and there are some examples like this. There's a lot of functions, so we will not, it's impossible to go through it one by one. If I go through this one by one, it's impossible to remember it in such a short time. So if you want to use any function, method, here, search, match, fill, match, split, any function or method, you can search on the internet. And we will not go through one by one. And also for the file manipulation, here we can manipulate a file, we can open a file, we can close a file, we can read a file, we can write contents into the file. Here, that is file manipulation. And for example, if we want to open a file, we can use this built-in function, that is open, and followed by the local address of your file. Here is my file, that is foo.txt file, and the mode of how to open the file is W. W means I want to write the file. So I will open the file, and we can write the file. Also, there are some attributes, properties of this file. We can check the name of the file. We can check if the file is closed, and we can check the mode of the file, the access mode of the file. And after all the operation, after all the manipulation process of the file, remember to close the file. So to close the file, we will use file.close. We will use file.close to close the file. Otherwise, the Python would. Otherwise, your file will never be closed, and you cannot open your file. You cannot manipulate your file in another way. So remember to close the file. So here is the method to write a file. We open a file, and the mode is write. And if we want to write a file, we can use file.write. So file.write, and after the writing process, we need to close the file at file.close. So after that, we can check the contents in the file. So that is the content in the file. That is the thing we write into the file. So also, we can only read the file. If we want to read the file, read only, and we need to change the mode to R+, open the file, and read, we can use read nice. That means the file will be read 9 by 9. So the file will be read 9 by 9, and the output will be the list, and every element in this list will be 1 line of this file. And also remember to close the file. And here's some other functions, and we can rename the file. We can rename the file, change the name of this file. And also we can read the file. Here we use read 9, that means read the file 9 by 9, and we can read specific characters of a file. For example, we only read 10 characters of a file. So here that is 10, it will output only 10 characters. So every time after the manipulation, we need to close the file, but also we can use the will, open.
Excuse me, ma'am.
Yes, please.
What does OS means in import OS and rename
What?
OS? Line 44. Import
For,
OS.
oh, in import OS. So OS is another built-in module in Python, and so we can use OS to read to read the folders from your own computer, to read the packages from your own computer, to get the current address of your of the current Jupyter notebook. So that is also a building function. Not a building mod. Also a module for in Python.
All right, thank you.
Yeah, it's the operating system. It's operating system interference. Yeah.
All right, thank you.
Okay. Okay, gosh. Wait a second. So here we've changed the name of this file. So here. We open it and close it. Wait a second. That is text 2. Yeah, text 2. Okay, change it to S. So every time after the manipulation of a file, we need to close the file. Remember, use file.close to close the file. But also we can use a wait statement. So we can use a wait statement like this. Here we use wait and open this building function, open the file, name of this file, the address of this file, and followed by the mode, we read the file, read only, and then as. So we this open as if, and in this loop body, the file will be opened. The file will be opened. When we jump out of this loop body, the file S would be closed. So there's no such file. It's a closed file. So usually we will use this wait statement to open the file. When we jump out of this loop body, and the file will be closed automatically. So here to delete the file, always we will use the OS. So this module C provide a lot of functions to interact with the operating system with our computer. So here to delete the file, we use os.remove. So the file will be deleted. When we want to open the file, you will see arrow. There's no such a file, so no such a directory. So that is the file manipulation. Sorry. So that's all for the Python programming, and we talk about the data structures, list, tuples, dictionaries, and the conditional loop, and conditional and looping statement, and how to define our own functions, and also object-oriented programming thought to how to create a class, how to inherit class, that is class inheritance, and how to create a parent child class based on parent class, and we talk about the private variable and the private method of a class. And the last three section we talk about some useful modules in Python. That is the import time, that is a module to process time in Python. And we talk about the regular expression, and this expression are very useful to match some certain strings from a document from a specific file. And we talk about the file manipulation. We can open a specific TXT file and read a file and write a file. And after the manipulation, we always need to close the file, and also we can use a wait statement to open the file. And when we jump out of the loop body, and the file will be closed automatically. So that is the key parts of the Python programming. So next, we may talk about, okay, we will have maybe 10 minutes rest, and then we will continue to talk about the programming. We will talk about the TensorFlow part. Okay, 10 minutes rest. Now we will continue. So wait a second. Before we continue to talk about the TensorFlow and also the math of HCIA-AI. Here's some useful link. Maybe some of you didn't pay attention to, so I want to emphasize again here. Here is a link to obtain the training materials. So the talent platform, and if you wait a second, I will show you. We click the link, open this talent platform, and you need to choose the technology direction, click AI, and here are a lot of training materials about AI. That is, we are learning HCIA-AI version 1. So here are the training materials, the lab guides, and just forget about the lab environment setup guides. So the most important and helpful is these training materials. So if we download the training material, it will be like this, just a PDF file of all these 6 chapters. And so if we open one chapter, so for example, the math chapter, so that is the PDF is a little bit different from the chapter from the slides we are using now. As the white slides, now we are using the blue slides. It's more maybe beautiful. And here for this white slide, it contains more words, contains more words. And so to prepare for the certification exam, you need to pay attention to the questions after each chapter. So pay attention to the white slides. For the white slides question after each chapter, for example, here are some quiz. Here are some quiz. So pay attention to this quiz, and you will be very helpful to prepare for the certification exam. So before we talk about the TensorFlow part, we will go very quickly to go through very quickly of the math basics. So the math basics, here is the agenda. It contains 3 parts, and the first and the second part are the most important part, and you can just ignore the third part because it's not that important, and you will not see any question from this third part. The numerical calculation, you will never see any question from this part. So maybe you will pay for this math chapter, you need to pay attention to the linear algebra and the probability part, these 2 parts, and to pass the exam. So we will not go through every detail, every term of linear algebra. This is not what we would do. So for these 2 chapters, we just need to remember the meaning of some key term, just like what is vector, what is matrix. So very easy. And what is a determinant of a matrix. And so the determinant of a matrix always will be a scalar. And so only square matrix can calculate the determinant. So the determinant of a square matrix is a scalar. So you may see a very similar question about this, about what I've mentioned. That is, you need to know what is determinant. So you need to know the square matrix determinant as a number, as a scalar. And some basic matrix operation is very easy: addition and manipulation. And scalar manipulation and some operations about matrix or some spatial matrices. So some spatial Y is identity matrix, Y is the diagonal matrix, and Y is symmetric matrix, and Y is orthogonal matrix. So this is very easy, and still also for the eigen decomposition for the part, you can just ignore this part. It talk about the eigen decomposition and the singular value decomposition. So forget about, ignore these slides. So for this first section, just remember some very, very basic knowledge about linear algebra. I believe all of you are very fully familiar with this operation about the matrix. And for the probability, so the key parts that you will see in the certification exam, that is what is the difference between frequency and the probability, and also some distributions, some commonly used distributions, like a binomial distribution, some spatial distributions. So the most important one is the random distribute, is a Gaussian distribution. So that is very easy. So that is the key part, that is the keyword from these two sections, and forget about the third section. So that is that is the math chapter. So remember some keywords from linear algebra, some spatial matrices, and some matrix operation. Y is determinant, and the probability remembers some commonly used spatial distribution. And that's all for this chapter. And okay. And for the math chapter, you just need to regard it as a reference book. If you have anything you forgot about the math chapter, you can check from this chapter, math chapter. If you are very familiar with this linear algebra and the probability, just forget about this chapter. So then we will move to the next part, and this is a very important part in our training session. Like TensorFlow, we will talk about TensorFlow, why is TensorFlow, how TensorFlow work. So TensorFlow is an AI framework from Google. Yeah, it's an AI framework from Google. It's open source, and it's the most popular, one of the most popular framework. PyTorch and TensorFlow is the most popular AI framework in industries. And here we will talk about some characteristic of TensorFlow. So here is some characteristic of TensorFlow. It's very powerful. It supports GPU, can use GPU or NPU to train our models using TensorFlow. It support cross-platform. It support cross-platform, and they support multiple languages, Java, Python, and C. And what does TensorFlow can do? It can create, it can train, it can deploy deep learning or machine learning models. And so what can TensorFlow do is, what can AI do? Self-driving cars, image recognition, language models, music creation. So here is an example. So this example is a style transfer example. That's very interesting example application of AI. So here is a very famous painting, that Starry Light. So here is a very famous painting. So for style transfer, we always got two input image. So the first image always be some famous paintings like this by Van Gogh, the Starry Light. And here is a picture from our daily life. So we can combine these two paintings. So what we want from this, we can combine these two photos, these two images. So what we want from this painting is the style of this painting. So the style of this painting, the style of the Van Gogh, and what we want from this photo is the content. It's the content. Is the content of this photo. So we combine the style from this painting and the content from this photo together, and it will become the final output, the mixed image. So that is style transfer. So that is what TensorFlow can do. And also an example for facial recognition. So detect where is a face in the image, and to predict how old is the face, how old the face looks like. So what TensorFlow can do, just and then we would talk about the TensorFlow basics. We would go through this first two sections very quickly, because this third one are the key section, are the key parts in this chapter. And also this online training, we don't have very sufficient time to talk about everything in detail. So we will focus on the key points. So key points to help you guys to pass the certification exam and the exam for the instructors. So then we will move to the TensorFlow basics. So what we learn, the version we learn is TensorFlow 1. So there will be a lot of terms in TensorFlow 1. First term we will discuss is this term TensorFlow, the name of this framework. Actually, the name of this framework, TensorFlow, this name is made up by two words. The first is tensor, and the second is flow. So tensor is a noun. So here, tensor actually means n-dimensional arrays. So actually, a scalar can be a tensor. It's a scalar can be a tensor, and the vector is also a tensor, and the matrix is also a tensor. And here, this is also a tensor. And wait a second, I will show you another image. So these slides give, so this slides give a more clear expression about tensor. Tensor is a multi-dimensional array. It's a multi-dimensional array. A scalar is a tensor. It's a zero-order tensor. It's not first, but zero-order tensor. Vector is a first-order tensor, like this. It's a first-order tensor here. And a matrix is a second-order tensor. It's a matrix. It's also a tensor. So here is a third-order tensor and fourth-order tensor. And so that is a tensor. So in TensorFlow, we can view tensor as a container. For example, there is a lot of containers, and these containers are separated physically. So these containers are used to store data. So that is tensor. Tensor are data, or you can view tensor as a container to store a lot of data. So here, flow is a verb, means the data would flow from the input to the output in TensorFlow. So to explain the word flow, we would introduce another term. We call it graph or computational graph. So in TensorFlow, every computation process would be converted into a graph. For example, here is a graph, like this is the input. So this is a graph. So the graph, in this graph, the data would flow from the input to the destination. So that is graph. We talk about tensor. Tensor is data in TensorFlow, and flow as a verb means the data would flow in the graph from the input node to the output node. So when we talk about graph, in graph, usually we got two things. The first is nodes, the second is edges. So in the graph is made up by a lot of nodes and edges. So a node means some operations, means represent the operations in TensorFlow, and edges represent the data and the relationship between nodes. For example, the edges represent data and the relationship between nodes. So in a graph, in a data flow graph, it contains a lot of nodes and edges. So that is tensor, that graph, nodes, and edges. So here is an example. So these are tensors. The tensors is a container, contains the BIOS input and the weights, and these represent the data operations and data operations to operate on this data. And here the entire computational process is a graph, is a data flow graph. So for TensorFlow, usually for TensorFlow to create a model, to train a model, usually we need two steps. The first step is we need to create a graph. That means we need to identify the process, the computational process of our model. So we need to tell the computer the computational process of the model, how the data will flow from the input to the output. So that is first step, to create a graph, but we will not execute the graph. So that is the next step. The next step is to execute the graph. How to execute the graph? That means we will feed the input into the graph. So here, actually, when we create a graph, there's nothing. We will not put the input value into the graph. So after the graph is created, after the graph is created, after the process that we tell the computer, the computational process, we need to feed the input value into graph. That is, we will light up this node, the input node, so that the input data will flow flows through the graph, flows through the edges to the nodes, through the edges to the nodes to the final destination. So in TensorFlow, usually we will separate these two steps. The first step is to create a graph. The second step is to execute the graph, is to feed. That is the feed mechanism, is to feed the data into a graph, into the graph, so the input data could flow from the input to the output then we can pick up the final result of this process, of this computation process. So that is tensor, graph, node, edges, and feed. We feed the data into the graph. So after we've created a computational graph, to execute the graph, we need to start a session. So after the session is started, we can feed the graph, or we can get the output of any nodes, of any edges. So this step is to create a graph and then start the session, and then feed input values into the graph and run the graph, and then we can fetch the value. We can fetch the value from the graph. That is a process of TensorFlow to execute the graph. That is a computation process of TensorFlow. And one question is why we need to separate these two steps. We need to create a graph, we need to create the computation process, and then execute the graph, then do it. That means we cannot debug during the creation of the graph. It's very inconvenient. But why the Google separate these two process, two steps? Any idea? So if there
can you ask again?
Okay, so my question is the reason why we need to create the graph first and then execute the graph and then compute in TensorFlow. So we need to create a graph and then start a session and feed the input into the graph. Why? Why we don't use the eager execution, or we don't use the mechanism like PyTorch? Just
the major reason is that the computation through tensors is very fast.
yeah, and then computation to tensors is very fast. So
yeah. So you can add more in that.
Okay, thank you so much.
I must say that
other
it's
Yes, please.
it's because that first you have to outline the model.
Yes.
So for outlining the model, you have to design it first. So you design the graph first, then you execute the model.
So why we need to design the entire graph first and then execute? Why not like PyTorch?
One more thing I want to add, that when we use GPUs, we can do parallel processing with using that TensorFlow. Maybe they are helpful. Popular processing.
Used for illustration purposes, like to explain more about it. The biggest idea about TensorFlow is that all numerical computations are expressed as computation graphs.
Any other?
Hello, could you hear me?
Yeah. Okay. Maybe I.
Yeah, I was saying that the graphs are actually used for illustration purposes, like to tell more about them, which would be easier to understand. That TensorFlow is that all numerical computations are expressed as computational graphs.
Yeah, the main reason why we separate these two steps, we need to create first to define the entire computation process, but not put the input value inside as that just like is that when we create the entire the entire graph, here is a node and here is the edges, here is a node, here is the edges, and so here is a node and here is the edges, and for example this is a graph, and we tell the computer the computational process of the graph, right? And but we will not execute, we will not feed input values into the graph. So the computer would allocate, so the TensorFlow would allocate the computing storage and the computing power properly to each node and edges. So maybe these nodes would spend the most of the computing power and computing edges. So it will allocate the most computing power and computing edges, and it will spend less, then this node spend less. So after the allocation of computer power and computer edges, and then we execute, and then we put input values into the graph. So the process of the training process will be accelerate. The training process will be faster, and the computing powers and the computing storage will be more properly allocated. So that's the reason why we separate the creation of the graph and the execution of the graph, separate these two steps. So I may use an example to explain why we do it. Just like here, maybe we can have a vacation, and we have 10 days free, and now we are going to traveling. We are going to travel somewhere, maybe from the starting place, maybe is Shanghai. We will start from Shanghai, and my destination here maybe is London. So Shanghai to London. Here, L means London. Okay. That is my goal. So that is my goal. Just like we create a model for image classification for object detection. That is my goal. So here is my final destination. Is to minimize the value of loss function. Okay, here's my goal. Now we need to identify the route. How can I go from Shanghai to London? So maybe first I will go to Beijing, and then I will go to Moscow, and then I will go to Paris, and then I will go to Amsterdam, and then the final destination, London. So that is my route. So before I start the journey, I got a plan. So I got a plan. As soon I got a plan, I can allocate my money and my time more properly. So I will allocate my money and my time. For example, here, maybe in Beijing, I will spend 2 days, and maybe $100, and in Moscow I will spend 3 days, maybe $200, and in Paris maybe I will spend 1 week and maybe $1,000. So I will allocate my money and my time more properly, just like TensorFlow. If I have a plan, if I have a route, I can allocate all my computing power and computing storage properly. So that's the reason why we separate the creation of graph and the execution of the graph in TensorFlow. So that is the basic concept of TensorFlow. We talk about why tensors. Tensors are data in TensorFlow, scalars, vectors, matrix, and are all tensors, but different orders of tensors. And we talk about graph as a very important term in TensorFlow, a data flow graph. So to create a model, first we need to outline the graph. We need to create a graph to tell the computer the specific process of our computation. So how our data will flow from the input node to the final destination, to the final output node, how. And so as soon as we create a graph, the computer would allocate the computing power and computing storage most properly. So, and then we can start a session. So that is, we can start a session and then we can talk with the graph. So we will give something to the graph and we can get some feedback from the graph. So how to talk with the graph, we can feed input value into the graph, and then the input value will travel by itself because we've only give it a plan. It can travel from the input. It will flow from the input to the final destination. And then after the computation, we can use fetch to pick up any value to obtain any value, to obtain the value of any node. So that is the basic term of TensorFlow. We talk about tensor graph, nodes, edges, and a graph is made up by a lot of nodes and edges. Nodes means nodes represent the operation of data, and edges represent the relationship between nodes and also data. In TensorFlow, we talk about sessions. We need to start the session to talk about, to interact with the graph. We need to start the session to feed input data to the graph and fetch the output value from the graph. So that is the basic concept of TensorFlow. And maybe, yes, not maybe, tomorrow we will talk about some TensorFlow programming based on Jupyter Notebook. So make sure all of you have already successfully installed Python and TensorFlow 1, not TensorFlow 2, TensorFlow 1. So if you install TensorFlow 2, it's okay. You can use tensorflow.compact.v1 version 1 to make your your programming, to make your codes in TensorFlow 1 works. So to make sure that your environment work, your TensorFlow work. So maybe that's all for today. Any other questions? So tomorrow we'll continue to talk about TensorFlow and the machine learning and deep learning part. Any questions?
We have to install TensorFlow 1.15, right?
Yeah, TensorFlow 1.15 or 1.30 or 1.18 are both okay.
Okay.
Okay, you mean 2.0 is not going to work?
2.0 would work, and you can use this command like import TensorFlow. If you import TensorFlow 2, you can use this command compact, if I remember correctly, as TF. So here you can use session, you can use placeholder, you can use finish the materialisms in TensorFlow 1. So use this command to import your TensorFlow. If you install TensorFlow 2. So for TensorFlow 2, import TensorFlow by this command. But we recommend you to import TensorFlow 1.50 or 1.30 or 1.80. Any other question?
I want to ask that I tried this command yesterday and I tried this command today as well, but it's not working. I don't know why. This import tensorflow.compact.v1stf. I'm trying, but it's not working.
Maybe you can, first thing you need to do is to check your TensorFlow version. As that is, use this command maybe. Sorry, tf version. So first, to check your TensorFlow version, if your TensorFlow version is TensorFlow 1, you just use import TensorFlow as TF. If your TensorFlow version is TensorFlow 2, you need to import TensorFlow using this command. So if you checked your TensorFlow version is TensorFlow 2, but you found this command doesn't work, you can take a screenshot and send me the email, and I will respond.
Okay, thank you.
Okay, thank you. Any other question?
Kelsey, I have still problem with WhatsApp, the WhatsApp group. I cannot join, sorry, not WhatsApp, it's WeChat group.
Yeah.
I am still unable to join that group.
Yes, some of you sent me the QR code, and I'm trying to scan the QR code to prove that you guys are not machines, but the QR code always expired. So it may seem it's impossible to help you guys to register a WeChat account. But okay, you can contact with me by email. So if you have any question, you can send me email. And here
Javed
again, yeah.
Javed sir, I'll ask you to share your WeChat ID with Kesar or Zishan sir, and then I'll add you to the group.
You mean share my WeChat ID to you?
No, Kelsey, I'll deal with this case. Don't worry. जावेद साहब आप अपनी आईडी जो है वो ज़िशान साहब के साथ शेयर कर दें, and then I'll add you to the group.
Okay. So if any of you guys already have a WeChat account, you can scan the QR code to help others to register the WeChat account. So thank you so much. Any other question? Okay, if you got any question, you can send me the email. And make sure that your environment works, the Python and the TensorFlow environment works before we start tomorrow. Okay, thank you. That's all for today. So.
Thank you, ma'am. Goodbye.
Thank you. Goodbye. Bye. Bye.
Kelsey, TensorFlow 1.8 version is fine?
You mean TensorFlow 1.0?
1.8.
Yeah, it works fine.
Oh, okay, thank you.
Okay, thank you.
Thank you.
Thank you.